Hello everyone. So in the previous lecture we had discussed about the Lagrangian multiplier method to optimize a multivariable function that contains a constraint. So continuing from there, we had done a numerical example in the previous lecture. So let us do few more examples on this Lagrangian multiplier method. So the question is that we have to optimize a function fxy which is equals to x square plus 4y square minus 2x plus 8y, and the constraint is that x plus 2y should be equal to 7. Okay, so this is the constraint that this function has, so we have to optimize it. So let's solve the equation and optimize the function. So as per Lagrange's method, basically what we have to do is we have to first of all the constraint has to be added into the function and create a new Lagrange's equation by using Lagrange's multiplier lambda, right? So let us form a equation that will have the Lagrange's multiplier lambda. So the equation will have the function value, that is x square plus 4y square minus 2x plus 8y. Then we will add a Lagrange's multiplier and we will add the constraint, that is x plus 2y minus 7. Okay, so this will be our equation. Then what we have to do is we have to partially differentiate this equation with respect to the variables that the equation have. That is, the equation has three variables. It has x, it has y, and it has lambda. So we are going to differentiate this equation with respect to these three variables. Sorry, partially differentiate this with respect to these three variables. So we will differentiate it with respect to we will partially differentiate it with respect to x. So on partially differentiating, we will have it 2x. This term will be 0 because we are partially differentiating. So this will be treated as a constant and will be 0. Then we will have 2, again constant 0, and in this whole expression we will have lambda. So we will have lambda and we'll put this equal to 0. Then we will differentiate it with respect to the other variable, that is y. We will partially differentiate it with respect to y. So we will have it as 8y plus 8 plus 2 lambda equal to 0. Then we will differentiate it with respect to the third variable, dl by the lambda. Then the equation will be, so all this will be 0 and we will have the equation as x plus 2y minus 7. Okay, so this is the partial differentiation, again putting equal to 0. So now we have three variables and we have three equations. This is equation number 1, this is equation number 2, and this is equation number 3, right? And we are going to solve this equation to find out the value of x, y, z, right? So solving by calculator, right? Solving by calculator. So if you are using 991 ms, I have already told you, you have to press the mode button 3 times. Through this you will be given the option to put the calculator in the equation mode by pressing 1. After this you will be asked that your equation have 2 unknown or 3 unknown. Here we have 3 unknowns, that is x, y, and lambda. So in terms of unknown we will choose 3, and the one thing that you have to be careful about is that this calculator takes the value in the form of ax plus by plus c lambda equal to d, right? So in this form you will be inputting the value, right? So after pressing 3 you will be asked the value of a1, right? And here we have the value as 2, right? B is variable for y, and since we do not have, we'll put it as 0. C is lambda, and here we'll put 1, and for D we'll put equal to positive 2 value, right? So likewise, you are going to put all the values. You are going to put A1, B1, C1, D1, A2, B2, C2, D2, and A3, B3, C3, and D3 values from these equations. Okay. If you have any doubt as to how to put this value, you can always ask. Okay. So on putting this value, the calculator will give you the answer. So your x will be equal to 5, your y will be equals to 1, and the value of lambda will be -8, right? So you will get the values. Okay. So now what you have to do is you have to apply the sufficient condition. Up till now we have applied the necessary condition. Now you are going to apply the sufficient condition and see what these values are giving. Okay. So in this we have already discussed in the previous lecture that you are going to form a matrix in the form of L11, L12, and going to input a variable to find out the if this is giving us maxima or minima. Okay. So we have the values Lij, that is if we are going for L11, so this will be L11, I will be 1, J will be 1. Okay. Here we will have I equal to 1, J equal to 1, and we are going to double differentiate it with respect to dx1 and dx2. Since in our equation we have variables in the form of x and y, right? So here we will have x and y, right? So let's apply the sufficient condition. So for L11 we will have d square L by dx square. If you are getting confused, just remember you have to first of all take equation 1 and you have to differentiate it with respect to the number of variable that you have. So the function value of this has two variable x and y, right? So we are going to differentiate equation number 1 with respect to x and with respect to y. This will be L11, L12. Okay. So differentiating it with respect to x again, right? So differentiating it with respect to x, we'll have 2 as our answer. This we will have 2 as our answer. L12 d square L by dx and dy. Okay. If you refer to this, if you refer here, so L12. Okay. This is L12. So here L12 we have L12, right? So here this is dx1, and if we put this in as per the formula that we have discussed, this is dx2, right? That is x2. So we have d square L by d over x1 d over x2, right? Conventionally I, and this is j, right? So here in this case we do not have x2. Here in the equation instead of x2 we have y, right? So this is d square L d over x and d over y. Okay. So let's put this. Since we do not have any y variable in the equation number 1, so this will be 0. Okay. Now we have L21. Now L21, in this case L21, so for L21 let's see, if I say L12, okay, so this is d over square L d over x1 d over sorry d over x2 d over x1, right? L2 L sorry this is L21. So we are finding L21, right? So this is d over square L divided by d over, here I is 2, right? So here I will be 2 d over xj, x j is in this case is 1, right? In our equation, you see we do not have x1 and x2. The equation is in the form of x and y, right? So here we will have it as d over square L, d over y, and d over x. So here L21 is d over square L divided by d over y and d over x. Okay, d over y and d over x. So differentiating equation number 2 with respect to x. Okay, so since we do not have any variable as x, so this will be 0, and then we have d over 2 2. So differentiating with respect to y, equation number 2 again differentiating with respect to y, so this will be d over square L by d over y square. On solving it, we will get answer to be 8. Okay, then we have differentiating the constraint. So d over g11, which is equals to d over g by d over x. So the partially differentiating with respect to x will have 1, right? Then we have d over g divided by d over g 1 2 back to y. So we will have with respect to y we will have 2. Okay, so forming the matrix, we have L11 minus the variable L12 G11, L21 L22 minus the variable G12, then G11 G12 0. This will be equal to 0. So putting this in this form, L11 is 2 minus the variable L12 is 0, so this is 0. G11 is 1, or let me just first of all put these value only. So 2 minus 0, then we have 0 and 8, 0 8, then we have 1 2 and 0. So solving it will have 2 minus 0 minus 4, then taking this minus 0, everything inside will be 0. So if this we are taking this, we are going to ignore this and this. So this is 0 into 0, 0 into 0 minus 2 into 1, 2 into 1, right? Then we will have plus 1. So when you take this, I am going to ignore these. So 0 into 2 and 8 into 1 plus 1. So this is 0 minus equal to 0, right? On solving it, we will have the value of the variable to be plus 3.2. Okay, so if the value of this variable is in positive, this means then the obtained point x comma y will give us the minima of the function. Okay, so we can say, since the obtained value of variable is positive, then the x comma y points, that is 5 comma 1, give minima of function. Okay. Okay, so this x comma y, that is 5 comma 1, gives the minima of the function. Right. So let's do another question. So question number 2, we have f x comma y equals to 9x square plus 36xy minus 4y square minus 18x minus 8y, and the constraint is 3x plus 4y is equals to 32. So this is our function and this is our constraint, and we have to minimize the function. We have to minimize the function using Lagrangian multiplier method. Okay, we have to minimize the function using Lagrangian multiplier method. Okay, so let's solve it. So the first thing is that we have to form a Lagrange's equation using Lagrangian multiplier lambda. So we have L, x, y and lambda. So that equation will be function value 36xy minus 4y square minus 18x minus 8y plus we'll add a Lagrange's multiplier function lambda, and then we'll multiply it with the constraint 3x plus 4y minus 32. Okay, so this is our equation, right? We have variables x and y and lambda in this equation. So what we are going to do, we are going to partially differentiate this equation with respect to x, y and lambda. So let us partially differentiate it with respect to x first. So on partially differentiating, we'll have 18x plus 36y minus 18 plus 3 lambda, and we'll put this equal to 0. Okay, so this is our equation number 1. We'll partially differentiate it with respect to y, and on partially differentiating, this will be 36x minus 8y minus 8 plus 4 lambda. This is again, we'll put it equal to 0, and this is our equation number 2. Okay, then we'll have partial differentiation with respect to lambda, and this is 3x plus 4y minus 32. If anyone has any difficulty as to how this partial differentiation is done, they can always ask. Okay, so we have 3 equations and we have 3 unknowns, so it can easily be solved. Okay, we have 3 unknowns x, y, z, x, y and lambda, and 3 equation number 1, equation number 2 and equation number 3, right? So let's again solve it by calculator. On solving by calculator, we'll have the value of x to be 8, value of y to be 2 and value of lambda to be minus 66. Okay, we'll have these values x, y and lambda values. Okay, so let's see at this point what are we getting. Are we getting a maxima point or a minima point? Okay, so for that what we'll do, we'll form a matrix and we will solve the equation. Okay, so let's find out L11. We'll find out L11. So for that, equation number 1 will be differentiated first in terms of x, so that will give L11, and then with respect to y, that will give L12. Okay, so for L11, double differentiating the equation number 1 with respect to x, right? So doing that, we will get, let me just write down dy square by dy x square for the equation 18x 36y minus 18 plus 3 lambda. 18x plus 36y minus 18 plus 3 lambda. So on solving it, we'll get 18 as our answer, because the rest other parameter will be treated as constant and will be 0. Okay, again for L12 d over x and d over y, partial differentiating equation number 1 now with respect to y. So which is equal to d over x d over y of 18x 36 y minus 18 plus 3 lambda. On solving it, we'll have this to be 36. Okay. Likewise, L21 this time partially differentiating equation number 2 with respect to x. Okay, so we have equation number 2, that is dl by dy. We will gonna partially differentiate it with respect to x, so dy by dx. So dy dx, equation number 2 is 36x minus 8y, 36x minus 8y minus 8 plus 4 lambda plus 4 lambda. Okay, so on partial differentiating, we'll have the value to be 36. Okay, we are differentiating with respect to x, so all the terms will be treated as constant and will be 0. Then we have L22. So this is now differentiating with respect, partial differentiating with respect to y. So we have dy square of 36x minus 8y minus 8 plus 4 lambda. So this will be equals to minus 8. Okay, so after this we have with respect to x, so partially differentiating the constraint will give 3, right, because the equation is 3x plus 4y minus 32. Again differentiating it with respect to y, the value will be 4, right. So forming the matrix 18 minus e 36 and this is minus 8, so minus 8 minus, then we have 3 4 and 0. Okay, putting it equal to 0. On solving it, we'll have 18 minus e. If anyone has any problem as to how this matrix is solved, they can ask. Minus 4 into 4 minus 36, right, 36 into, so this will be 36 into 0 and 3 into 4. So this is 0 minus 12 plus 3, 36 into 4 minus 3. Okay, so on solving it, you will get the value of e to be minus 25.920. Okay, since the value is negative, so at this point we are getting maxima. Okay, since the value of variable comma y, value of variable is giving negative, so the point x comma y, that is, what were the points? 8 comma 2 are giving maxima. Okay, so the points are giving maxima. Okay, so this is how the Lagrangian method is done. Try to do it by yourself. If you have any doubt in any of this stage, you can always ask. Okay, So that's it for today. Thank you.